Okay, so we're on Chapter 7, Lesson 6, which is Use Algebraic Expressions. Our learning objective is you will use variables to represent unknown quantities and write algebraic expressions to solve them. So our essential question, how can you use variables and algebraic expressions to solve problems? Sometimes you have an unknown number that you need to solve a problem. You can represent a problem like this by writing an algebraic expression in which a variable represents the unknown number. Okay, so we're going to look at a couple examples here. Rafi's flight from Los Angeles to New York took 5 hours. He wants to know the average speed of the plane in miles per hour. Write an expression to represent the average speed of the plane. So, in order to do this, we're going to use a variable to represent the unknown quantity, which the unknown quantity right now is the average speed of the plane in miles per hour. So think, the plane's average speed is equal to the distance traveled divided by the time traveled. We know that because distance equals rate times time. Okay, so if we do distance equals rate times the time, to get that over to find out the rate, we do distance divided by time. So we're going to use a variable to represent the unknown quantity. So we're going to let D represent the distance traveled in units of, okay, so we're trying to figure out distance, and up here it tells us miles per hour, so we know that the traveled the units of miles. Now we're going to write an algebraic expression for the average speed. So we have D miles, and we're going to put in 5 hours because it says right up here 5 hours. Okay, so that's how we would set that up. Distance divided by 5 hours. Distance divided by time. Now Rafi looks up the distance between Los Angeles and New York on the internet and finds that the average distance is 2,460 miles. Use this distance to find the average speed of Rafi's plane. Okay, so we're just going to substitute in what we did, just like we did lesson 5. So we're going to plug in what we know. So we know now that D equals 2,460 in this particular instant. So write the expression, D miles divided by 5 hours. Now we're going to substitute 2,460 miles for the D. So now we're going to divide the unit, divide to find the unit rate. So we're going to take 2,460 divided by 5. And remember, real quick, unit rate means compared to 1 unit. So if we're going to divide that by 5, we need to divide the bottom by 5 so that we get a unit rate of 1 right there. And divided by, divided by 5, we're going to look at that. 5 goes into 24 4 times, which is 24, 6. We're going to do 5 times 9, which is 45. 1, 0, and 2, 10, 0. So 2,460 divided by 5 gives us 492 miles per every 1 hour. So the plane's average speed was 492 miles per hour. In the problem on the previous page, the variable represented a single value, the distance in miles between Los Angeles and New York. In other situations, a variable may represent any number in a particular set of numbers, such as the set of positive numbers. Okay, that'll make a little bit more sense once we look at this example again. So our example is Joanna makes and sells candles online. She charges $7 per candle, and shipping is $5 per order. So any order is going to be $5 to ship, and $7 for a candle. So write an expression that Joanna can use to find the total cost for any candle order. So we're going to think. The number of candles a customer buys will vary from order to order because I might buy 2 candles and you might buy 17 because you like candles. Who knows? So let N represent the number of candles, because that's what we're talking about, a customer buys, where N is a whole number greater than 0. So N for me would be 2, and for you it would be 17. Okay, now we're going to think the cost per order equals the charge per candle, so that is $7, times the number of candles purchased. Well, it's different for me than you, so that's where we're going to let N represent that. So 7 times N plus the shipping charge is $5 for every order. So an expression for the total cost of a candle order is just going to be 7N plus 5. In March, one of Joanna's customers placed an order for 4 candles. In May, the same customer placed an order for 6 candles. What was the total charge for both orders? So we're going to find the charge in dollars for each order. So we're going to write the expression, which we have right here. And that's the expression for March and May. Okay? Those are 2 different times, but we're going to use the same expression. Now we're going to substitute the number of candles ordered for N. Well, if we look up here, in March, she placed an order for 4 candles, and in May, she placed an order for 6. So we're going to substitute the number of candles for N, so we're going to say 7 times 4 in March plus 5. And in May, we're going to do 7 times 6 plus 5. Now we're going to solve that according to PEMDAS. We're going to take, following the order of operations, we would multiply before we add. So 7 times 4 is going to be 28. And 28 plus 5 will be 33. And in May, we have 7 times 6, which is 42. 42 plus 5 is 47. Step 2, find the charge in dollars for both orders. Okay, so now we're just going to add those 2 together. 33 plus 47. Add those up. 7 plus 3 is 10. 1. 4 plus 3 is 7. Plus 1 is 8. So we have 80. So the total charge for both orders was 80. Do not forget your units. $80. So all we're doing is combining everything that we've already done into one problem.